All right, good morning. This is your stats sensei, Mr. Spensey, and we're going to be going through the test review. This video will be on the hypothesis test, and then the following one will be on the confidence interval. So, our scenario, and we'll be using the scenario for both. When a law firm represents a group of people in a class action lawsuit and wins that lawsuit, the firm receives a percentage of the group's monetary settlement. That settlement amount is based on the total number of people in the group. The larger the group and the larger the settlement, the more money the firm will receive. So a law firm is trying to decide whether to represent more than 1,000 car owners in a class action lawsuit. So this is big number. This is probably my population. We'll keep reading to check that out, but that looks like my population to see of a certain make and model for a particular defect. If 5% or less of the cars of this make and model have the defect, the firm will not recover its expenses. Therefore, the firm will handle the lawsuit only if it's convinced that more than 5% of the cars have this defect. So, a random sample of 755. Okay, so we have a random sample. That's good to know. Of 755. So that's 755 out of 100,000 who bought this car were asked if they experienced a defect in the cars and found that 46 people had experienced this defect. Test at a significance level of 0.03. All right, so here's our alpha. So it looks like we have a sample size of 755. Sounds like we have 46 people with a defect. Determine if more than 5%. So we want to know if it's greater than 0.05 or greater than 5%. All right, so it sounds like we know what we are. It sounds like we've identified most of our important information. Let's get to working on this. Well, first off, I'm going to go ahead and record some of our important information and our hypothesis. Well, they wanted to know if it's more than 5%. So baseline is, hey, it's 5%. Remember, you always set it at an equal sign. Some people might be tempted to put less than. It's never less than, just use equal. They wanted to know the probability that it was more than 5%. So P is greater than 0.05. So when I go to plug this in over here, I know that this is 0.05. That's my P. My sample size, when we were reading this, we said, oh, the sample size of 755, and we have an X of 46. So this is 755. This is 46, and P hat will just be 46 over that 755. And let's go ahead and get that as a decimal. So 46 divided by 755. Oops, not natural log. 46 divided by 755. And we get about 6%, so 0.0609. So far, this is looking pretty good for taking the lawsuit. So 0.0609. All right. So our parameter. Well, what do we care about? We want to know the proportion of people who bought this car that have the defect. And once again, I can kind of look at the prompt. It says if more than 5% of the model have the defect. So that's what we're looking for. So let P equal the true population proportion of cars that have this defect. I don't know what this defect is. They didn't tell us, but some sort of defect. Okay. So the formula. Well, it's going to be, we're doing a hypothesis test for one proportion Z. So it's Z equals P hat minus P over P times 1 minus P over N. All right, so now we need to get to our conditions. Well, the first one's easy, and everyone seems to be doing really well with this. They look to see if it's a random sample. They almost always tell us it is. So we have a random sample, happens to be of size 755. and that was given. So that's good. We're taking care of that. The next thing is the n is less than 10%. All right, and that in this case, our n happens to be, you know what? I've swapped these things here. That's a mistake. This needs to be 46. My x is 46, and this is 755. I hope y'all caught that. I didn't catch it till just now, but at least we divided that right. It's still 6%, but this should be our x is 46, our n is 755. So n is 755. Now we're going to multiply that by 10. Again, this is something from what I'm seeing on your papers looks pretty good. So if I take the calculator, I'm just going to do this real quickly, 755 times 10, and we get 7,550. And that happens to be less than, well, what was our population size? Oh, we said our population was about 100,000. So, all right, 7,550 is big, but it's less than 100,000. So that's taken care of. All right, here's where we're I'm seeing some issues. Make sure that first off, we're using P here, not P hat. So this is going to be NP has to be greater than 10. So we need to show everything here. So that's going to be 755 times P. Well, what was P? P is 5%. So 0.05. So now we need to go ahead and multiply that out. 755 times 0.05 equals 37.75. And that's greater than 10. That's supposed to be a greater than sign. So that part's good to go. Then the next part is n times 1 minus p has to be greater than 10. Now this right here is for normality. So 755 times 1 minus p, which is 1 minus 0.05. So we're going to plug that in. So 755 parentheses 1 minus 0.05, close it. And we find it's 717.25 equals 717.25. That's clearly greater than 10. So our conditions happen to be met. All right, so we're good to go there. We should look at our graph, and I should have already done this, but at least we have it now. What did we have? Well, our claim was 5%, so that's where my center is. My center is based on that claim, 0.05. When I look at my alternative, and I do need to take a look at my alternative, I need to move that. My alternative said that, hey, it's supposed to be greater than, so this needs to be greater than, tells me the direction I'm shading, and I sit there and go, oh, 6% is greater than that, so this is 0.0609 right here. So this is my p hat. This is what we got from the sample. This is my sample statistic, 0.0609. And we're shading this way. Technically, we're going to positive infinity. Over here is negative infinity, but this is the area that we're looking for. All right, we need to start plugging our values into our formula. And we need a greater than. So we want the probability that z is greater than 0.0609 minus 0.05. Make sure for the hypothesis test, we use P in the radical. So 1 minus 0.05 over our sample size of 755. All right, continuing on. Stat test. Number 5, which is one proportion z-test. So we have a claim of 5%, so 0.05. Right here, we say we have an x of 46 and an n of 755. And we said we were going to shade to the right, so this is a greater than. We calculate, and I end up getting 1.3776. So the probability that z is greater than 1.3766 gives me a p-value of 0.084. All right. So our p-value is 0.0814. So they test at a significance level of 0.03. Huh. Well, how about that? This is larger. Our p-value is larger. When our p-value is larger, we fail to reject HO. That's interesting because even though we got a sample statistic that's greater than 5%, it's not far enough great for us to be confident about it. So we're not going to reject it. We're going to believe that it's 5%. We're not going to do it. We needed it to be this. So they're not going to go with this lawsuit. So our conclusion, our P value is 0.0814. We fail to reject the null. There is not, there's not enough, there's not sufficient evidence at alpha equal 0.03 to suggest that the true population proportion of cars with defects, and by the way, that came from here, the true population proportion of cars that have this defect. That's the, I mean, so basically we just restated the parameter is, and I need to go look at what my alternative is. Well, what was my alternative? Oh, greater than 5%. All right. So appreciate you watching. Hope that helped. Hope to see you on the next one. The next one will be the confidence interval for this same particular problem. Thanks a lot. See you on the next one.